Okay, good afternoon, ladies and gentlemen. To another lesson in intermolecular forces. Up till now, we have already discussed um, dipole-dipole forces, um, which originates because of a polarity difference between two atoms of the same compound. Uh, from there on, we moved on to dispersion forces, which we recognized uh, was exhibited by every and any molecule that you'd study in chemistry, and they're exhibited because of the number of electrons that are present, because the electrons result in what we call an induced dipole, which creates that dipole attraction, or which creates that temporary attraction which is responsible for the intermolecular force. Today we learn about the strongest, weakest force out there, which is hydrogen bonding. Um, and in effect, hydrogen bonding is just the extreme case of dipole-dipole interaction. So the first thing that we could write down is hydrogen bonding is just the extreme case of dipole-dipole interaction. Of dipole-dipole interaction. Oh, sorry, I forgot. Thank you. Uh, but what's so special about hydrogen bonds is that hydrogen bonds will only occur when hydrogen is bonded to either of these three: oxygen, fluorine, or nitrogen. The bond has to be between oxygen, hydrogen, and nitrogen, and only then would a hydrogen bond occur. It is a really strong intermolecular force. An example that I could show you of a hydrogen bonding would be HOH, that is water, being hydrogen, uh, developing a hydrogen bond between another water molecule. And carefully observe what happens here. You have these lone pair of electrons on oxygen, and these would be obviously negatively charged. And you have a partial positive charge on the hydrogen here. That partial positive charge results is is because the oxygen is highly electronegative and it is pulling the electron away towards itself. That gives it a positive charge. Now, the attraction between the lone pair of the oxygen atom in the water molecule and the hydrogen in the adjacent water molecule results in hydrogen bonding. That is an example of hydrogen bonding. Now, that could happen in any molecule where you have a hydrogen bonded to either an oxygen, fluorine, and nitrogen. Only these three are accepted. Anything else, it's just dipole-dipole interaction. With oxygen, fluorine, and nitrogen, it's hydrogen bonding. Now, a quick question that I would want you to think about in the next 1 minute is, in this molecule below, which of the hydrogens are capable of hydrogen bonding? I'll pause here and let you do the thinking. Thanks. Which ones of these are um, capable of hydrogen bonding? Now, it has to be attached to either oxygen, fluorine, or nitrogen. That's criteria number one. So that fulfills the criteria. That does not fulfill the criteria because it's not attached to a hydrogen, it's attached to a carbon. This does not, these two do. So it's these three hydrogens which are capable of hydrogen bonding. Now, hydrogen bonding by itself is the most important concept that you learn about in intermolecular forces. When you go on to organic chemistry in year 12, nearly, if there are 10 questions asked from hydrocarbons, 6 of them would require an understanding of hydrogen bonding. As long as you can understand the concept that it's either it has to be a hydrogen attached to oxygen, fluorine, and nitrogen, and also it has to have lone pairs, and the lone pairs are responsible for the hydrogen bonding between. So the lone pairs are responsible for the attraction between the molecule and another molecule which has hydrogen. You should be fine. So you need to get these concepts in your head. Um, if you have understood that, you should be able to do question 5, 6, 7, 8 from set 25. I'll give you 5 minutes per question. That gives you 20 minutes to do these 4. Thanks. So now that you have attempted the questions from set 25, I'd like to move on to the next topic, which is discussing the relationship between melting and boiling points and intermolecular forces. How does one influence the other? What does it mean to have strong intermolecular forces? What effects does it have on the boiling point or the melting point? And I'm not only interested in what effect it has, I want to know why that is. So I want a full-fledged answer. So if this is let's say I put this in a test, I know it shouldn't be more than 2, but I'll put it for 4 marks. How are you going to explain in explicit detail why this is the case? So I'm going to pause this now, and I'm going to give you a couple of minutes to work with your partners to decide your answer. Thanks. Okay, the way to answer this question, given that it is 4 marks, would be to first identify the outermost layer of the onion, or the broadest point that you could start off with. And that broadest point would be melting and boiling point increases. Melting point increases, boiling point increases as the intermolecular forces increase. Now, the next thing that you would need to add is this is because as the intermolecular forces become strong, there is more kinetic energy expended or more energy required to break the bonds between 2 molecules. This would mean that the boiling point or the boiling point and the melting point of that molecule would increase. That gives you 2. Now what do? Well, you just take an example. For example, water has a boiling point of 100 degrees Celsius. This is because water exhibits dispersion forces, dipole-dipole forces, and hydrogen bonding. And hydrogen bonding is the strongest force in the 3 forces, which results in a high melting and boiling point. However, nitrogen or fluorine just exhibits dispersion forces, which is a weak force. This would mean that that less energy would be required to break the bonds apart. Hence, the answer. And that's it. 4 marks secured. And you knew that already. I mean, there's nothing new in which you could have said this in 2 lines, and I know that you know, but the examiner doesn't know that. You just have to make your thinking clear. Next one. Now, how do you explain this trend? We have 2 trends here. Let's call this part A. Let's call this part B. You would see that the melting point is going up and the boiling point is going up as you move down from fluorine, chlorine, bromine, and iodine. Same thing here. In the second trend, same thing. The boiling point goes up as you move from propane to methoxymethane. Now this is called methoxymethane. You don't need to know that right now, as long as you know the molecule. I just want you to look at the molecule and judge the kind of forces that it has. And then finally CH3CHO, which is ethanol. Again, you don't need to know this. We will do this in detail. I'm going to pause it so that we can get some answers, and then we'll discuss it. Now, some information that I've missed probably in the past is the definition of debye. Now, debye is just the unit of dipole moment. Unit of dipole moment. If you're wondering what dipole moment is, dipole moment is a measure of polarity, which you qualitatively have an idea. That means you could just look at look at, let's say, C3H8, and you could, or you could look at CH4, and you could say that, okay, that's a non-polar molecule because the shape of the molecule is tetrahedral. Or let's take the example of chlorine. You know that chlorine is non-polar because you have two chlorine atoms and both of them are pulling the electrons, so the electrons would be dead in the center. So it's a non-polar molecule. So the unit, the answer or the numerical value of the dipole moment, something that tells you the polarity, would be 0 debye. That means it's non-polar. If anything has a positive dipole moment, that would mean that it is polar. So in this case, this has C3H8 has a 0 dipole moment, CH3COCH3 has a 1.3 dipole moment, that means it's polar, and then finally ethanol has a dipole moment of 2.7 d. Now with that information, now knowing that dipole moment is just a measure of polarity, can you use that to your advantage to explain the trend in part B? Okay, so for the first one, in which we have fluorine, chlorine, bromine, and iodine, all you have to say is that as you go down the group, you can see that the melting and the boiling point increases. Now you explain why that happens. That happens, or this is because as you go down, the size of the molecules increases. As the size of the molecules increases, the number of electrons in the molecule increase. Since the number of electrons determine the dispersion forces, bigger molecules have stronger dispersion forces. Therefore, iodine will have the strongest dispersion force and hence the highest boiling point, whereas fluorine, which has the lowest, smallest dispersion force, will have the smallest boiling point and melting point. That. Part B, as you go down, you can see that the boiling point is increasing. This is because as you go down, the polarity of the molecules increases. Since polarity decides the dipole, since polarity decides the dipole forces, so therefore the greater the polarity, the greater the dipole force of attraction. In this case, CH3CHO has a polarity of 2.7 debye. That means that it will have the strongest dipole forces, whereas C3H8 has a polarity of 0 debye. That means it does not have dipole force, it just has dispersion forces. Hence, it will have a stronger boiling point. Now that could be a 4-mark question at Silver.